Okay, in this numerical example, we have two cascaded operational amplifier and we have to figure out what is the final output, V out. Okay, so if we look here, we have Zener diode and Vz is equal to 5. So, like, if we ignore this Zener diode and we apply voltage divider, maybe it's going to work, but hold on, there's a silicon diode here, and that silicon diode is in reverse bias mode. So as long as we are applying a constant and stable DC source here, this silicon diode is in reverse bias mode, which means we have open circuit. That means this branch is not is like open up and it's not active even if we provided sufficient voltage for Zener diode in order to operate as a voltage regulator. That means you don't have to be worried about this branch because you have a silicon diode in reverse bias mode, and whatever the voltage is provided here, as long as it is DC, you don't need to worry about it. Okay, so like the whole branch here is not working in this case, and you can just like ignore it and proceed without worrying about this Zener diode anymore. So now again I P is equal to IN and it's equal to 0, and VP is equal to PN. So the current here is equal to 0. Okay, so I here is 0 and same here, and that leaves what? That leaves also the voltage at this point is equal the voltage at this point. Now I'm looking for V out, so it's going to be a good idea to find V out 1, let me call it here. So I'm going to apply voltage divider. I have to know the voltage here, so it's going to be 8 by 12 times 15, which is equal to 10 volts. That means it's going to be 10 volts here and 10 volts here. Okay, so like the direction is going to be like this. The direction here, we have the feedback current is coming like that. So the current here, like it's going to be, I can say this is here 12, like minus 10. I'm applying Ohm's law is equal I times 4. That means I here is simply equal to 0, like 2 by 5.4 milliamps. So I can write KCL, I can say it is like minus 0.4, and here minus V out 1 minus 10 by 8, because RF1 is equal to 8 is equal to 0, so I can say this is going to be plus, this is going to be plus. So if I multiply this by 8, for example, this is going to be 3.2 plus V01 minus 10 is equal to 0. So that leaves V out 1 is going to be 6.8 volts. That means now the voltage here, VO1, is equal to 6.8 volts. So let me highlight this. Okay, now here we can see this operation amplifier, and obviously this is grounded, so the voltage here basically is going to be 0. And since the voltage at this point is equal the voltage at this point, that means here we have 0. So I can say now the current which passes, let me change the color, the current which passes this 4 kilo ohm is going to be simply let me do the calculation here. Okay, so I can simply say it's going to be VO1 minus 0 is equal 4 times I. So that means I for the like for the 4 kilo ohm, okay, is going to be okay 6 by 8, sorry 6.8 by 4, and it's equal to 1.7 milliamps. So this is for the 4 kilo ohm resistor. Okay. So the current here is 1.4 milliamps, and here is the current going to this node, and here we have the second feedback current coming to this node. So now simply we can find V out using node voltage method. Okay, so we can say like minus, now minus 1. Okay, so we can see the circuit a little bit. Okay, let me zoom out. Okay, so minus 1.7, now minus V out, okay, which I'm looking for, minus 0 because the voltage here is 0 by 16 is equal to 0. So again, this is, that means this is plus, this is plus. Okay, I'm just stressing about this minus and this minus, and later on I'm multiplying by minus just to show you that my reference when the current is coming to the node is negative, current which is leaving the node is positive. Okay, so that's the point that I'm like I would like to highlight, and that means if you multiply this by 16, it's going to be 27.2 plus V out is 0 equal to 0. That leaves V out is going to be minus 27.2 volts. And that's our answer. That's the answer for this numerical problem. So V out simply here, V out simply equal to minus 27.2. That's it. And thanks for watching.